Okay, so we are going to be learning the basics of functions in Python and really kind of generally in all computer programming. But of course, we're dealing with Python, so the syntactical things will be Python specific. So basically, a function in programming is just like a function in math. It takes in several inputs and it gives out several outputs. It takes in inputs, gives outputs. So it takes in 0 to however many inputs, and it gives out 0 to however many outputs. So you might give it some numbers or some things. It might do some things. It might, do some stuff to those things and give that out, or it might just do some things and not give anything out, or it might take in no arguments and take in no inputs and give out something. So we'll look at all of those sort of different things in this introductory video. But the basic syntax for a function in Python is you start with def. This means like define, and then I'm gonna write the name of the function. I'm just gonna call it my function, and then you do open parentheses. And now inside the parentheses, you put all of the arguments that it could take. So maybe it takes in 2 arguments, let's say x and y. Then you put a colon, and anything underneath, anything that's below this line and indented is called the body of the function. It's what happens when you call the function. So I'm just going to do something very simple. It's just going to print out these 2 numbers, x and y, and maybe their sum as well. So print this plus this equals this. Dot format x, y, x plus y. Okay, now what's happening within Python? Actually, let me do this as an example. So I'm going to come down here and do my function 1 and 17. Okay, so now what's happening when I run this code? Actually, let me even make it a little more specific. So I'm going to run this line of code, and now inside of Jupyter, it knows there's this thing called my function. When I reference my function, it knows it knows it's referring to this. So now, whoops, that's not what I wanted. That was the link for the last video. So I'm going to do my function 1 and 17. Now, what's going to happen when I run this code? Python is going to say, okay, or Jupyter or whatever is going to look in its list of variables. It's going to say, okay, I have a my function. I know what my function is. It's a function. It's going to come up here to the definition of function, and it says, okay, it takes 2 arguments. All right, yes, 2 arguments were given, 1 and 17. And then, okay, well, what do I do? Well, here's the first instruction. It's to print blank plus blank equals blank, where the first thing that goes there is x, whatever the first argument is. Whatever goes there is the second argument, whatever the second argument was, and whatever goes there is the third argument, which is, or sorry, the sum of the 2 arguments, which is x plus y. So when I run this code, it should print out 1 plus 17 is equal to 18 when I run this code. Okay, 1 plus 17 is equal to 18. Okay, so just playing around with this, if I come up and I make this y, and I make this x, and I run this, now the code is going to be backwards, or the inputs would be backwards. So here, remember, x is the second argument, so that right there, when it gets printed, is going to be the second argument. That will be the first argument, and that'll still be the sum. So when I run this code, it will say 17 plus 1 equals 18. Okay, so the order of the argument matters. Notice, I'm going to put this back like I had it, so x and y. I could come up here and I could say x is equal to 17 and y is equal to 1. And think about what's going to happen when I do x and y. So one thing that I'm trying to I want to illustrate with this point is something called scope. So here in the scope of this cell, x is equal to 17 and y is equal to 1. So when we call this function, Python says, okay, in the scope of this cell, x is 17. So I'm going to put a 17 there. Y is 1, I'm going to put a 1 there, and I'm going to run this function. I'm going to call this function, and the first argument is going to be 17, and the second argument is going to be 1. So when I print this out, it should say again, 17 plus 1 is equal to 18. Oh, sorry, it says 1 plus 17 is equal to 18. Oh, I need to run this again, sorry. Okay, so 17 plus 1 is equal to 18. Okay, on the other hand, if I change this to 1 and this to 7 and this to 17, in this scope, x is equal to 1, and that's the first argument, and y is equal to 17, and that's the second argument. But if I come down here and flip this, this will be y, and this will be x. So now 17 is going to be there, and 1 is going to be there. So the first argument to the function is 17, and the second argument is going to be 1. When I run this, I get the same thing again. So even though, up here, x is equal to 1, when it comes up here to the function, the first argument, which we're calling x within this scope, is equal to 17 because that's what y is equal to. So because the fact that I'm calling the variables x and y here, once I come up to the function, within the scope of the function, x and y are also defined in this scope of function, in the scope of this function. And so what's going to happen is Python is first going to go to the most local scope, which within the function is these variables x and y, and use those values, which would be the first argument passed to the function and the second argument passed to the function, and use those values. Okay, now let me show you one of the big dangers with Python. So I'm going to change the argument to x and z here. So I'm going to do x and z. But now I'm going to format what I'm going to make the arguments. I'm going to call the arguments x and z, but I'm not going to change this part right here. Okay, and let's try to think what's going to happen if I'm going to run this code. If I run this code, okay, so this is something that should not happen. This is one of the dangers of using Python, because what happens when you run this program, it's going to come up here, and Python says, okay, in the scope of this program, in the scope of this function, I mean, x is equal to 1, and z, or x is going to be the first argument, which in this case would be 17, because that's the first argument to this function when I call it. The second argument is going to be 1, because that's the second argument that gets passed here. Okay, good with that. So when it comes down here and tries to access the variables, it knows what x is, because within the scope of this program, again, it goes from the most local scope outwards. So within the scope of this function, x is the first argument that was passed, which in this case is 17. But now it needs to figure out what y is. So notice that within the scope of this program, there is no y variable. So then it goes to the next scope out, which is kind of like a global setting here. And since I've defined what y is within this instance of Jupyter, Jupyter knows that y is equal to 17. It says, okay, that must be the value of y that we want to use. So this is one of the dangers of Jupyter, is that it allows you to use, it allows you to kind of use these global variables in ways that you might not want it to. So I'll just point that out. I just wanted to point that out. So let's talk a little bit more about functions. A function, there's no reason that a function takes any inputs or does anything. It could just be this, and I could write return. Whoops. Okay, so the return statement, what the return statement does is this is just saying this is the end of the program. Now you don't have to write this, but every program needs to have a line. So if I call my function, if I do this now, it's just not going to do anything. Okay. On the other hand, sometimes I might have a function that takes in nothing, returns nothing, and it just, prints a statement. Let's say the common one would be hello world. So if I load that and then run it, it gets hello world. Okay, sometimes it might take a variable and then not actually do anything with that variable, though that would, I guess that's a little strange. And so on and so forth. But oftentimes what we're doing is we are taking in some variables, doing something with those variables, and returning something. So let's just say I have a weird function. Why you would want to do this, I don't know. Whoops. It's just going to return the sum of the two arguments, x plus y. So now I'm going to run this. If I run this, let's say 5 plus 6. So now what's going to happen, I do my function 5 plus 6, 5 comma 6. What's going to happen is Python's going to say my function, okay, I know what that is. It's going to come up here to the definition and say, okay, in this case, the first argument is 5, the second argument is 6. So I'm just going to return the number x plus y, or 5 plus 6, which is 11. And now here it's going to store that number 11 in the variable z. So if I just run this code, we're not going to see any output. But then if I print z, we will see 11. Okay, so this is kind of, just basic introduction to functions. But why would we want to use functions? I mean, some of you might already be seeing how this would have helped the Collatz homework. But in general, functions allow us to abstract concepts that we might be doing over and over again and just encapsulate them into one area of the program. And so all of the work can be focused in this one area of the program, and I'm writing a function that does one specific thing, and I can focus my attention on writing this function that other people will use, and I'm not having to I can just basically focus on this one thing at a time without having to worry about how the other parts of the program are going to use it. I mean, I do have to worry about that, but I'm not having to worry about all of, for example, in the Collatz thing, there was a bunch of nested loops. Well, functions will, if we had the ability to use functions, or if you had the ability to use functions and you used them in that program, you would see that actually would have made things much easier, just allowing you to sort of abstract and focus on one thing at a time. So let's say, I'm not saying that there's any reason that this would come up naturally, but let's say you have a program where you're going to need to compute the log of x squared minus 1 divided by x minus 1. Like this, you have some program, and for whatever reason, this is a computation that you're going to have to do a lot. I'm just going to leave it up there. Some of you know you can change this to markdown, but whatever. So let's say we want to have to do this computation over and over again. Well, if we think about this, I can't really just put that line of code wherever I need it. Like I can't just always do np.log x squared minus 1 divided by x minus 1. And the reason is because the domain of this function is a little complicated. Okay, so x squared minus 1, for this to work, x squared minus 1 needs to be bigger than 0. Okay, so just from a mathematical perspective, for this function to make sense, I need to have x squared minus 1 being greater than 0. On the other hand, x can't be equal to 1 because we have problems with the denominator, or at least, again, from a mathematical standpoint, x can't be 1. So 1 is not in the domain of this function, and x squared minus 1 has to be greater than 0, which means the absolute value of x has to be bigger than 1. Okay, so now what do we do in cases like where x is equal to 1 or minus 1, or what, in cases like that, we need to figure out how we're going to handle this. Okay, so I'm going to write a function. I'm going to start off here from sort of just kind of basics of how the function would go, and then kind of make adjustments to this function as I go. So I'm going to call it a log function because I'm using logs. It takes in one variable x. Okay, and most basically is going to return np.log x squared minus 1 divided by x minus 1. Now we know there's going to be, I need to do parentheses here. Python follows standard order of operations. Okay, so this is the function, and here I'm going to test. So if I do log function of, let's say, 10, I should get some reasonable output. On the other hand, if I try one of the edge cases, let's say plus or minus 1, I should get an error because I'm going to be dividing by 0. Okay, so there's an error here, divide by 0. If I do minus 1, I'm not going to get a divide by 0, but I'm going to get a log of 0 error. And so again, there's a problem here. Now, what's happening in this problem, this function and the other one, Python tries to help you out and give you some output that helps, which in this case, they're calling it minus infinity. Okay, so at least we're getting some output. If we try something like 0, we're going to get a similar story. This case, not a number. Okay, but the idea is we want this function to handle those out of domain cases. We wanted to handle it in the way that we think it should be handled. So let me pull up the graph. So this is the graph of the function. So if we think about what's going on, if we put in anything between minus 1 and 1, we should get some kind of error. Like there really is no good way to assign a definition if the number goes from minus 1 to 1. If we're using real numbers, if x is strictly bigger than minus 1 and less than 1, it really should return nothing. Okay, so or maybe do some sort of error message. So if minus 1 is less than x and 1 and x is less than 1, we're going to want it to do one thing. Okay, let's just say we're going to want it to return let's say we like the idea of returning not a number, NaN. So we can do math.nan. Okay, and so now what's going to happen is whoever calls this program has to be prepared for the fact that they might get an output of not a number. Maybe that works for our program, maybe not. Notice this is exactly what we would have gotten if we hadn't have done anything. I'm sorry, it's exactly what we would have gotten if we hadn't have had this message here. In other words, if I run this program, I'm going to get not a number. Sorry, I need to run this line. Okay, so now if I run this, it's just going to get not a number, but it's not giving me the warning because it's not getting, like, the program logic is not getting to this point. So it's not giving a warning now, which is good. So it says we're in control of what happens. Okay, so now let's see what we want to do when we return one of these other outputs. So on -1, you know, positive infinity would be a very reasonable output, and on 1, minus infinity would be a very reasonable output. But let's just say we don't, like, we want to consider that to be not a number as well. Okay, so now we could say if x is equal to -1 or x is equal to 1, return math.not a number. So now we've taken care of, so if x is not in the domain of the function, this will take care of one case, this will take care of the other case. Of course, I could add all of this up here as well, and it's going to behave in the way that we want it to. So if I return this, okay, so let's test it. I should get not a number. Okay, this is good, and I get -1. And so Python's not giving us a warning because it is not having to do this, like, it gives us the warning when it has to figure out something to do. That's not like when it has to somehow, you know, assign a number or assign a symbol or something to something that is otherwise not defined. Okay, so this is great. Now let's say we have this computation in our program a gazillion times. And then let's say we realize, well, actually, we don't really want to return not a number here, and we don't really want to return not a number there. Let's just say, for whatever reason, this doesn't really make a whole lot of sense, but let's just say for whatever reason, in this case, if x is between -1 and 1, let's say instead of returning not a number, we want to return 0. So now, instead of having to make this change every single point where this function is used, I can just make the change at this one function here, run the code, and now I'm going to get 0. Okay, again, in this case, 0 would be an interesting interpretation for what this should be. But the point is to illustrate that there are times where maybe you initially want to have a function do one thing and every time it gets used, but then you realize really it should be doing something different. And now if we hadn't had functions, we would have had this whole statement written. If I'm using this idea, this log x squared minus 1 over x minus 1, if I'm using this in a lot of my code, if I want to change how it behaves, I'm going to have to go and change every single spot in that code. Whereas if I use functions, I just have to change it with the function. And not only that, from a psychological standpoint, if there's something wrong with this function, I can just focus on this function, like I can just focus on this and fix this one thing without having to immediately worry about everything else. Now, of course, if people are using this, you're going to have to make sure that it gives a reasonable outputs. So 0 being a reasonable output might make sense for this function in a particular context. Otherwise, it might be the not a number thing that you want to put here or something completely different. Okay, so this is the idea of functions. In the next video, I'm going to show how we can use functions specifically in the Collatz thing.